Okay, so now we're doing a review of systems. So the very first thing we want to talk about is isolating x or y. Sometimes we want to, if we're graphing, we always want to get y by itself. But if we're doing substituting, we could get x or y by itself. So the first thing you need to do is move the constant. If there is a constant on the same side of the equal sign, then move that constant to the other side using addition or subtraction. And then move the variable you're not isolating to that other side also. And then divide by the coefficient if it's something other than 1. So this first one says solve for y. So this is what I want to get by itself. So I'm not going to do anything to it first. I need to move this to the other side of the equal sign. So this cancels out here, so I'm left with negative 4y equals, remember, you cannot add in, you can't combine 24 and negative 2x. 24 does not have an x in it. You can't combine it. Now, the next step is, I want that y by itself, but it has something multiplied by it. So I need to divide everything by that negative 4. When I do that, negative 2 over negative 4 gets me 1/2 x minus 6. Okay, so this time it says we're solving for x. So that means I need to move the negative 4y to the other side. The opposite of that is a plus 4y. So I'm going to add 4y. I'm going to bring the negative 2x straight down. 4y plus 36. Then, again, I don't want the negative 2 in front of the x. Right now, it was multiplication, so I'm going to divide. So that's going to get me negative 2y minus 18. Okay, this next one. I want y by itself. So this is positive 6x. The opposite of that is minus. So we're going to subtract 6x. I bring the 4y straight down, the equal sign straight down, the negative 6x straight down, and the plus 12. I don't want the 4 that's sitting in front of it, in front of the y, so I'm going to divide by 4. Now, 4 does not go into 6 evenly. 2 goes into both of those numbers. So I'm going to simplify my fraction. But 4 does go into 12 evenly. Okay, and this last one, we're solving for x. So I need to move the 2y to the other side. The opposite of adding 2y is subtracting 2y. So I bring down the negative 6x. The negative 2y plus 12. I don't want the negative 6 in front of the x, so I'm going to divide everything by that negative 6. I get x equals, again, 6 doesn't go into 2 evenly, so I need to simplify my fraction. Now, some of you may have said, but on that one you had 3 and the x in the numerator together. Guys, I can write that like this too. Y over 3 minus 2. Either way. So the next part, we're going to decide whether it's one solution, no solution, or infinitely many solutions. Okay, so this first one, do they ever run into each other? No, they don't. So that means that it's no solution. This next one, they run into each other at one spot, so that means it's one solution. This one, these are two lines on top of each other, so this is infinite. Oh, I can't spell today. Infinite solutions. Okay, this is kind of like what we were doing the other day with our special cases. So if they have the same slope, that means they're going the same direction, but they don't have the same y-intercept. That means that it's going to be no solution. Same slope, same y-intercept. That means it's the same exact equation. So that means it's infinite solutions. And if they have different slopes, that means that there is going to be one solution. Okay, so we need that information to do these, to make sure that we understand these next ones. Okay, so if I look at this first one right here, look at that. This first equation, that is not solved for y. So I can't do anything until that is solved for y. So I'm going to come out over here and I'm going to solve for y. I want the y by itself, so I'm going to add 3x to both sides. And I get y equals 3x minus 2. So my y-intercept for this one is 2. My slope for this one is 3, which is 3 over 1. So I'm going to go to 0, 2. I'm going to go up 3, 1, 2, 3, and over 1. Or down 1, 2, 3, over 1. 2, 3, over 1. And I'm going to draw my line. Okay? Then I'm going to do a different color. On this one, my slope is 3, which is 3 over 1. My y-intercept is negative 2. So I'm going to come down here to negative 2. I go up 1, 2, 3 over 1, 1, 2, 3 over 1. And look at that. Those are parallel lines. They never run into each other. Guys, that have the same slope but different y-intercepts. No, it didn't. Let me redo that problem. Negative 3x plus y equals negative 2. I add 3x to both sides. Y equals 3x minus 2. It's the exact same equation. This is infinite solutions. So that's negative 2, up 3 over 1, up 3 over 1, and I draw a line. Over here, this top one, it has a y-intercept of negative 8. It has a slope of 2. 1, 2, 3, 4, 5, 6, 7, 8. Sorry about that. Up to 1, 2 over 1. 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 2 over 1. 1, 2 over 1. Okay. The other one. So I need y by itself. So that means I need to subtract x from both sides. I get negative y equals negative x plus 7. Divide everything by negative 1. And I get y equals x minus 7. Okay, so I go down to negative 7. And I go up 1 over 1. Up 1 over 1. Look at that. They ran into each other right here at the point 1, negative 6. That's hilarious. So many things I need to fix. So this one, its y-intercept is the 0.06. Its slope is negative 1/2. So I go 1, 2, 3, 4, 5, 6. down 1 over 2, down 1 over 2, over 2, down 1 over 2. Hopefully they run into each other on this. Oh, goodness gracious. So I'm going to subtract 2 from, or subtract x. I'm going to get 2y equals negative x plus 4. I'm going to divide everything by 2. I'm going to get y equals negative 1/2 x plus 2. Did I do that right? I did. Oh, look at that. Same slope, different y-intercept. They are parallel lines. This time they are actually parallel lines, so this would be no solution. Okay, number 14. This one right here has a y-intercept of negative 3. It has a slope of 1 or of 3, which is 3 over 1. I go down to negative 3. I go up 3 and I go over 1. Up 3 over 1, up 3 over 1, or down 3 over 1. And I draw my line. The second one, it has a y-intercept of 0, 0. It has a slope of 3 over 2. So I'm going to go up 3, 1, 2, 3, and over 2. They ran into each other. 1, 2, 3, over 2. So where did they run into each other? At 2, 3. Okay, this top one has a y-intercept of 2. It has a slope of negative 1/3. So down 1 over 3, down 1 over 3. Or I could have gone up 1 over 3. Oops, that was weird. Didn't want to. 1, 2, 3. I was having a hard time there for a second. Okay. And this one, I need the y by itself. I'm going to subtract x from both sides. I get negative 3y equals negative x minus 6. I can make it a little bit bigger. Divide by negative 3, negative 3, negative 3. I'm going to get y equals 1/3 x plus 2. Did I do that right? I did. Look at this. But the slope is 1/3. Not negative 1/3. But they run into each other at the y-intercept. That is the solution. This one. That's going to be down here, right here. Sorry. That's this line. And that's going to be a horizontal line down here. And then negative 3, 1, 2, 3. That's going to be a vertical line. Right. Come on. Oh, it's not going to do it. Usually all I have to do is hold it there for a second. The point where they run into each other right there is the point negative 3, 8. Okay, when we have substitution, that means we have to have one of the variables solved for it. So, look right there. It already has x by itself. So I'm going to take what x equals right here, and I'm going to plug it in for the x. So the negative stays right where it is. I plug in 8 plus 5y. Notice how the negative is on the outside of the parentheses. Plus 7y equals negative 2. So then I multiply the negative through. Remember, that's a negative 1. So negative 8 minus 5y plus 7y equals negative 2. And we solve this just like we've been solving equations. So that would be plus 2y equals negative 2. Add 8 to both sides. Get 2y equals 6. Divide by 2. And get y equals 3. Now, mind you, we've got the y value now, but we still need the x value. So we're going to plug that in to the first equation that we had. We are going to replace what the y value is, which is 3. So 8 plus 15, that's going to get us 23. 23, comma 3. Okay. Next one. Look at this. They both are y equals. So all I'm going to do is I'm going to take this and I'm going to plug it in right there. 5x plus 9 equals negative x plus 9. You just set the two equal to each other. And then you solve. So I get 6x plus 9 equals 9. Hopefully you notice something about that. You divide by 6, and yes, 0 is an answer. So our x value is 0. Now we need to find our y value. So I'm going to plug it into the first one. Did it matter which one I plugged it into? Nope, it did not. So 0 plus 9 is 9. So the solution is the 0.09. Okay, so now we're going to come to this one. We already have y equals, so we're going to take what y equals and we're going to plug it in for the y. So we have a 6x plus 2, and then we're going to replace the y with negative 3x plus 5 equals 10. So all we did was take the y away and plug in what y equals. So that's going to get minus 6x plus 10 equals 10. This is going to get 10 equals 10. That is true. So this is infinite solutions. Okay, on this one, we do not have a variable by itself. Now, I'm going to say to pick the x. Why am I going to say pick the x? The reason that I'm going to say that is because it doesn't have a negative in front of it, and it has the number 1 for the coefficient. So I'm going to write it down here, and I'm going to move the y to the other side of the equal sign. So x equals y plus 3. I'm going to take this right here, and I'm going to plug it in for that x that's right there. So I'm going to do negative 6. I'm going to replace the x with y plus 3. And I'm going to keep the rest of the equation exactly the same. Now, I'm going to multiply the negative 6 through. I'm going to combine like terms and get negative y minus 18 equals negative 9. I'm going to add 18 to both sides. I'm going to get negative y equals 9. I'm going to divide both sides by negative 1. And I'm going to get y equals negative 9. So for the solution of this, I've got negative 9 for my y value. Now I need to figure out the x value. So I plug it into either the first equation or the second equation. I'm going to plug it into the first equation. So I'm going to replace the y with negative 9. So that's going to get me x plus 9 equals 3. I'm going to subtract 9 from both sides and get x equals negative 6. So it meets at the point negative 6, negative 9. Okay, so this one, I look at the two equations and I find the one that has a 1 for the coefficient. That is this one right here. So I'm going to solve for that first. I'm going to subtract 6x from both sides of the equal sign. I'm going to get y equals negative 6x plus 14. I'm going to take this right here, and I'm going to plug it in for that y that's right there. Okay, so I have negative 10x minus 2. I'm going to replace the y with negative 6x plus 14. And I'm going to write equals negative 20. So all I've done is replace the y. That's the only thing I've done. So negative 10x plus 12x minus 28 equals negative 20. Combine like terms and I get 2x minus 28 equals negative 20. I'm going to add 28 to both sides of the equal sign. I'm going to get 2x equals 8, divide by 2, and get x equals 4. So now we have what x equals. I need to figure out what y equals. So I'm going to plug it into the first equation. And I'm going to replace the x with what x equals. X equals 4. So I'm replacing that. So 24 plus y equals 14. I'm going to subtract 24 from both sides, and y equals negative 10. Okay, so this one tells me that this is what x equals. So I'm going to replace x right here. So I have negative 2. I'm going to replace the x with negative 2y plus 2 minus 4y. Oops, I meant to change the color. Minus 4y equals negative 6. So I'm going to distribute that. Get 4y minus 4 minus 4y equals negative 6. I'm going to combine like terms and I get negative 4 equals negative 6. Nope. So that's no solution. Okay, so now we have elimination. And remember with elimination, you have to line up the variables and get them so that you can add them together and they have the same, or they have opposite coefficients. So let's look right now at these first two. Actually, we're going to skip that one and we're going to come to the second one. I don't know why that one was first. Do you see how these are opposites of each other? So all we're going to do is add the two together. That's going to get me, this is going to get me 0. Oh, look at that. 0 equals 0. Does that work? Yep, that's infinite solutions. Let's look at the next one. I don't want to do that one. I want to do this one. Okay. So my question is, they're not opposites of each other, but the negative 5 and negative 5, they're the same. So how could I get them opposite of each other? What I could do is I could multiply this whole thing by negative 1. If I did that, I would get 2x plus 5y equals positive 29. And now I'm going to add these two equations together. Get 10x, that's going to go to 0, and that's going to go to 20. Divide by 10 and get x equals 2. So now we have figured out what the x value is. Now we have to figure out the y value. So you pick one of the two equations. It doesn't matter which equation. I'm going to pick the second one. Oops. Minus 5y equals negative 9. So I'm going to replace the x with 2. So I'm replacing the x with 2. And I get 16 minus 5y equals negative 9. I'm going to subtract 16 from both sides. I'm going to get negative 25. I'm going to divide by negative 5. And I'm going to get y equals 5. So the solution for this is the 0.25. Now we're going to go back to this one right here. Now, we do not have coefficients that are the same or opposites of each other. So that means I need to multiply one of the two equations by something in order to get opposites of each other. So I'm actually going to look at the coefficients of x. Because doesn't negative 2 go into negative 4? 2 goes into 4 evenly. So I'm going to deal with that. Okay? So if I was to multiply this by 2, that would give me the negative 4. But I want them to be opposite. So I'm going to multiply it by negative 4. So I'm going to write down the first original equation. Okay? And then I'm going to multiply by negative 2 on the second equation. And when I do that, look at the coefficients of x. If I look at the coefficients of x right here, they are now opposites of each other. So when I add these two equations together, those cancel each other out. So then I get negative 19y equals negative 38. Because all I did was add straight down. Divide by negative 19, and I get y equals 2. So I have my y value. My y value is 2. And now you just pick one of the two equations. It doesn't matter which one. I'm going to pick the first one, negative 4x minus 3y equals negative 18. I'm going to replace the y with 2. So negative 4x minus 3. I'm going to replace the y with 2. And I'm going to solve this equation. So negative 4x minus 6 equals negative 18. I'm going to add 6 to both sides. Negative 4x equals negative 12. Divide by negative 4 on both sides and get x equals 3. Okay? So x equals 3. The solution to that is the 0.32. Okay, so now let's go to this one. Now, when you see a coefficient that is 1, that is sometimes the best one to multiply by. Or you can look at right here, and if I multiply the second equation by 2, I don't have to multiply by a negative. Now, why would I multiply by 2 on the second equation instead of multiplying by negative 8 on the first equation? The reason why I would do that is because negative 8 is much harder to multiply by than multiplying by 2. So I'm going to multiply this by 2. So I'm going to take my first equation and I'm going to write down my first equation as is. I didn't change my first equation at all. I'm going to change my second equation. This is going to be 16x minus 8y. Look at that. The coefficients of y are opposites of each other. That's what the whole point is. So now I'm going to add these together and I'm going to get 17x. These cancel themselves out and that's going to be 0. So I divide by 17 and I get x equals 0. So our x value is 0. Now I have to take one of the two equations. I'm going to take the first one. So I have x plus 8y equals negative 24. I'm going to replace the x with 0. So that just gets me 8y equals negative 24. I divide by 8, and I get y equals negative 3. So the answer to this is the 0.0, negative 3. Okay. I think this is the last one, or I have 2 more, sorry. Okay, so I could multiply, because this has a 1 here, I could multiply this whole thing by 10, or I could multiply it by 2. I'm going to multiply it by 10. So I'm going to write down the first equation as is. Why did I decide to do by 10? Just because. And some of you are going, oh my gosh, those are huge numbers. Exactly why I was saying sometimes it's not or it's easier to multiply by the 2, that if you had multiplied here by the 2, it would have been a much easier problem. Okay, so when I do this, I'm going to get 64y. Is that right? Yes. And this is going to be negative 256. And I'm going to divide by 64. Oh my gosh, these dogs. Negative 4. So my y value is negative 4. Which one am I going to plug it into? I'm actually going to plug it into the second equation. Nope, the original second equation. X plus 8y equals negative 25. So x plus 8 times negative 4 equals negative 25. So x minus 32 equals negative 25. I'm going to add 32 to both sides. And x equals 7. So it's the 0.7 negative 4. And last but certainly not least, ooh, look at this. These are both 4s. I could just multiply this one. Oh, actually, I'm going to do the other one. I'm going to multiply this one by negative 1. Anybody know why I did that? It's so that I could just write the problem right underneath and not have to rewrite the whole thing again. Add straight down, I get 10x. These cancel each other out, negative 30. Divide by 10, x equals negative 3. Then I plug it back into one of the 2 original equations. I'm going to take the second one because the exponent, or the coefficient of x, is positive. That's the only reason I did it. So I'm going to replace x with negative 3. Okay, so this would get me negative 9 plus 4y equals negative 25. Add 9 to both sides. 4y equals negative 16. Divide by 4 on both sides and get y equals negative 4. So this is the point, negative 3, negative 4. Oops, sorry about that.